So hello my dear students, today we are going to talk about a new concept, that is annihilating polynomial of a matrix. The concept is very simple and it is very interesting as well. So over here a polynomial f of lambda is said to annihilate a matrix A if f of A is equal to 0. So what is the meaning of this? So meaning is simple. Now we have seen the characteristic polynomial. We have also seen the Cayley-Hamilton theorem. So what does the Cayley-Hamilton theorem say? Every square matrix satisfies its own characteristic equation. So we have already come across the concept of annihilating polynomial in case of what? The Cayley-Hamilton theorem. So what is actually happening there? So whenever we think of a characteristic polynomial, it is given by determinant of xi minus a. So by Cayley-Hamilton theorem, the matrix is satisfying this polynomial, means we are having f of a is equal to 0. So the meaning is that the characteristic polynomial is annihilating the matrix A. Are you getting my point? That is what is happening. Because if you are having a certain matrix A, suppose, and suppose your characteristic polynomial is x cube plus x square plus minus x plus 1, let me say. So by Cayley-Hamilton theorem, what is going to happen? Now since this is your characteristic polynomial, so by Cayley-Hamilton theorem you will have a cube plus a square minus a plus I is equal to 0, and that is nothing but what? That is nothing but f of a is equal to 0. It means that this polynomial is annihilating the matrix A. Annihilating in the sense it is killing the matrix A, because if you put x is equal to A on the right hand side, what you are getting? 0. Okay, I hope you got the meaning of annihilating polynomial. So that is the best example, that characteristic polynomial is annihilating a matrix A. So I will say here example characteristic polynomial, I will say characteristic polynomial f of x is equal to determinant of xi minus a annihilates. And if you want to take another example, so if you have some matrix B, suppose, and if you are having some polynomial f of x is equal to, let me say, some x square plus 1, and if this is satisfied, and let me say f of a is equal f of b now, isn't it? And suppose this is happening, f of b is equal to b square plus I is equal to 0, then what we will say? This f of x, so you can say that is we can say, I will say, when we say b f of x annihilates what? B, isn't it? Okay, so I hope you are getting the point of the annihilating polynomial. Now next is the definition of monic polynomial, which we have already seen. So polynomial is said to be monic if its leading coefficient is 1. So a characteristic polynomial is an example of monic polynomial, or you can take any example of your choice. For example, if I are having x to the power 5 plus 6 x raised to 6 plus x raised to 4 plus x cube plus 1, is it a monic polynomial? The answer is no, it is not monic, because the degree of the polynomial is 6, isn't it? Because x raised to 6 is present and its coefficient is 1. So what do you mean by monic polynomial? The coefficient of the degree term should be 1. Okay, so if I take x to the power 7 plus 5x raised to 6 plus x to the power 3 plus 2x square plus 9, now in this case it is going to be monic, because degree of the polynomial is 7, and you can see the coefficient of x raised to 7 is 1. So this is the meaning of monic polynomial. Now here comes our important concept that we are going to discuss today, that is the minimal polynomial. Very important concept, which will be required in your higher classes as well, and which are required for your MSc entrance examinations also. So I think a lot of MCQs will be asked on this topic. Monic polynomial of least degree which annihilates a matrix A is said to be, is called as minimal polynomial of a matrix A, not monic. It should be what? Minimal. So a monic polynomial, we already know what is a monic polynomial, which annihilates the matrix A, but it should be of least degree. I mean, if you think properly, if you take some matrix, just for explanation, if you take certain matrix A, for example, and suppose we already know that we already know one polynomial that is annihilating this matrix A, and which is that the characteristic polynomial. So our characteristic polynomial that is f of x is equal to determinant of xi minus a is going to annihilate, means what? We are going to get f of a is equal to 0, but it is not guaranteed that it is of least degree. Okay, so what is the degree of f of x? It depends on order of the matrix A. Suppose my order of the matrix is 3, then the degree of f is going to be 3. Then it means that f is a polynomial having degree 3 such that f of a is equal to 0. But there is no guarantee that it is of least degree. I mean, there may be a polynomial of degree 2 for which we are getting f1 of a is equal to 0, or there may be some f2 polynomial of degree 1 for which f of a may be equal to 0, right? So whatever the polynomial is annihilating a, if that polynomial is of least degree that we know, then that polynomial is said to be a minimal polynomial. Okay, so if I will say f of 2 is of degree 1 and it is annihilating a, suppose, then, and that is only the polynomial of least degree, or you can say there is no polynomial having degree less than 1 which annihilates a, then that f2 is going to be what? A minimal polynomial. Okay, or you can say, suppose since this characteristic polynomial is annihilating a, and suppose there is no polynomial of degree 1 or 2 which is annihilating the matrix A. Remember, 0 polynomial is always going to annihilate a matrix A, isn't it? So we are not going to think of that. Okay, so our minimal polynomial is always going to be non-zero. Okay, so don't think of that polynomial. So, and obviously don't think of a constant polynomial. Constant polynomial will never annihilate, I guess. Okay, so if I am having identity matrix 1 0 0 0 1 0 and 0 0 1, so which polynomial is going to annihilate it? I guess f of x is equal to x will annihilate, x minus 1 will annihilate, I guess. Yes, x minus 1 will definitely annihilate this matrix, because what will happen is, if you try to calculate a minus I, so we are talking about the identity matrix over here, that is, I will call it as B. So what will be my f of B in this case? F of B will be B minus I, and B is already identity matrix, right? So it will be I minus I, which will be equal to 0. So therefore you can say that in this case this f of x is equal to x minus 1 annihilates B. Okay, so but one thing is 100% sure. Okay, whatever your minimal polynomial is there, okay, so the degree of the minimal polynomial is 100% not going to exceed the order of the matrix, isn't it? I mean, suppose you are having some matrix A, suppose, and the question is asked, find the minimal polynomial, and suppose the order of the matrix is 3. So the minimal polynomial is either going to have degree 1, 2 or 3, isn't it? Because you already know the polynomial of degree 3 which annihilates A, that is the characteristic polynomial. So only we are supposed to check whether there is any other polynomial having degree 2 or degree 1 which is annihilating A. That's all you have to check. If you do not get that polynomials, then definitely your minimal polynomial is going to be what? The characteristic polynomial itself. Okay, so this is the rough idea of the minimal polynomial. Okay, and there are few notes now, but the question is how to find the minimal polynomial, isn't it? So therefore there are some notes that we are going to